Hey there! In today's video, we're going over the 2015-2016 TMSCA General Math Test number 1. Let's do it.
Alright, number 21. Use the examples below to find the value of n. Alright, so in this type of problem, if you look at these patterns right here, right, these four triangles, you might see, how do you do a formula for this? What is the pattern for this? Well, in reality, there is no formula. There's no method I can teach you to solve this. You just have to be able to guess the pattern. So in this problem, I'll just tell you what the pattern is, because that's all you can do. So 3, -7, and 13. So it's in a triangle like this. Alright, so 3, -7, and 13. So first we have the number 3. So the thing is, if you do the negative of whatever this number is, so -7, that gets you 10. And then you just add this first number back. And that gets you this last number right here. So that's the correlation. So all you're doing is, you're taking this top number, so in the next one, let's say 5, and then you're subtracting the second number, which is this right here. So let's subtract 3, which is 2, and then add the first number. That's 7. So if we use this pattern for this one right here, because that's what we're trying to solve. We're trying to solve for what n is. So we can see 8 minus 14, that's -6, and then -6 plus 8, that's 2. And that's your answer. Now, if this seems really confusing, don't worry, because it's confusing for everyone. There's no set pattern you can find to solve it. There's no set formula. It's always different. It's the hardest problem in the entire test. Next, what number below is the multiplicative inverse of the number 5 and 3/8? Alright, so the multiplicative inverse, that is nothing but the reciprocal. The reciprocal is just when you flip the fraction around. So for example, 1/2, the reciprocal of 1/2 is just 2 over 1. So you're just switching the number on the bottom and the top. Alright, so you have to figure out the multiplicative inverse, or the reciprocal, Alright, so we have to find out the multiplicative inverse, or the reciprocal, of the number 5 and 3/8. But before that, we first have to turn it into an improper fraction, because we can't do it in its mixed number form. So we have the number 5 and 3/8. So the way we turn this into an improper fraction is we multiply the denominator and the number right here, which is 5, and the denominator is 8. So that's 40. And then we add this top number, which is the numerator, so that's 43. And then we just keep the same denominator. So that's 43 over 8. Next, now all we have to do is flip these. So we just flip the numerator and the denominator, and that's 8 over 43. And that's your answer. Next, how many lines of symmetry can be drawn in a regular pentagon? Alright, so the very simple way to explain this is, if you have a pentagon, right, there's 5 sides to a pentagon. That means there can be 5 lines of symmetry drawn. So the answer is 5. So the formula is, however many sides there are, that's the amount of lines of symmetry that can be drawn. So 5 your answer. Next, using the picture below, choose which pair of angles represents a pair of alternate interior angles. Alright, so alternate interior angles share the same measure, but they're on opposite sides of a line, and they're inside these two parallel lines. So they're in between these two. So in this scenario, we can see that there are only 2 pairs of angles that work. 4 and 5, and 3 and 6. But if we look at our answer choices, there's no 4 and 5. There's only a 3 and 6. So that's your answer. Next, let n equal the digit in the 10,000s place in the number 345,687. Find the value of 5n minus 8. Alright, so the 10th thousands place is just the 5th number from the beginning. So we have 7, 8, 6, 5, 4. So 4 is a digit in the 10,000s place. And now we just have to substitute 4 in for where n is in this equation. So that's 5 times 4 minus 28. So 5 times 4 is 20, and 20 minus 28 is -8, and that's your answer. Next, Clint wants to convert 5/6 into a decimal. Which of the following is 5/6 converted as a decimal? Alright, so all you have to do is 5 divided by 6. So we can quickly do that. So 5, 6. So 6 obviously doesn't go into 5, so we can just put a 0. Next, we go into the invisible numbers, so that's just the point zeros. These have no value, but you have to do them to do the division. So 6 can go 8 times into 5.0, because that can be looked at as 50. So that means 8 times 6 is 48, which is less than 50. So we can subtract 2, and then we bring down another imaginary 0. How much times does 6 go into 20? 6 goes into 20 3 times. So that gives us 3. And next, we can subtract the 18, which leaves us with 2. Alright, now we can see that we have 2 twice. That means it's just going to be 3 over and over again. So we can say that it's 0.8333 repeating to infinity, right? But how do we write that? Well, I actually said this earlier in another problem in another part of this series. However, I'll explain it one more time. So, if you have a number that's repeating like this, right? Instead of writing it out like this, you can just write it as 0.8, and then whatever number is repeating, you can just put a line over it. So since the 3 is repeating, you can just put a line over the 3, and now you get you 0.83 repeating, and that's your answer. Next, what is the sum of all the positive integral divisors of the number 24? Alright, so the first step in solving this problem is finding the prime factorization. So I actually have a full video on how to find the prime factorization, which will be linked in the pinned card at the top. But let's continue with this problem. So 24 can be split down into 2 and 12. 12 can be split down into 2 and 6, and 6 can be split down into 2 and 3. Alright, so we can no longer divide this number anymore because these are all prime numbers. A prime number is a number that can only be divided by 1 and itself. So this is how we create our prime factorization. So we have the numbers 2 and 3. So we have to give these each a power. So we can give 2 the power of 3 because 2 comes 3 times. So 2 power 3. And 3 can have the power of 1 because it only has 1 appearance. Alright, now we would multiply these. And that is your prime factorization. Next, we need to use this to find the number of positive integral divisors. Again, I have a full video on this, which will be linked in the pinned card at the top. But let's continue with this problem. So 2 cubed times 3 power 1. So we can raise the power of both of the exponents. So 2 power 4 times 3 power 2. So now the 3 has gone to 4, and the 1 has gone to 2. Alright, so that becomes our new exponents here. Next, we need to take these and do 2 power 4 minus 1 over this base number, which is 2, 2 minus 1. And this is multiplied times 3 power 2 minus 1 divided by this base number, which is 3 minus 1. And when you solve this, you'll get the sum of all the positive integral divisors. So let's solve. 2 power 4 is 16. 16 minus 1 is 15. 15 divided by 2 minus 1, that's just 1. So that's just 15 divided by 1, which is 15. So 15 times 3 squared minus 1. 3 squared is 9. 9 minus 1 is 8. 8 divided by 2 is 4. So that's 15 times 4. And that's 60. And that's your answer. Next, 4m squared plus 6m minus 8 minus 11 minus 3m plus 4m squared. Alright, so you have 4m squared plus 6m minus 8 minus 11 minus 3m plus 4m squared. Alright, so all we have to do is we have to be able to combine the like terms. The first what we have to do is we have to see this negative and distribute it into this values. So negative of 11 is just negative 11. Negative of negative 3m is positive 3m. And negative of positive 4m squared is negative 4m squared. Alright, now we can put this with 4m squared plus 6m minus 8. And now we just combine the like terms. So first up, 4m squared. 4m squared and negative 4m squared cancel out. Next, we have 6m plus 3m, that is 9m. Finally, you have negative 8 minus 11, that is 19. And that's your answer. Next, what is the ninth term in the sequence? Negative 2, 3, 1, 4, 5, 9. Alright, so in this sequence, you can see that negative 2 plus 3 is equal to 1. And then 3 plus 1 is equal to 4. And then 4 plus 1 equals 5, and it keeps going on like this. So then 5 plus 4 is equal to 9. So just adding the number before it to itself and getting the next number. That's called a Fibonacci sequence. So how do we find the 9th term? Well, we're already on the 6th term, so we just have to keep combining. So 9 plus 5 is equal to 14. That's your 7th term. 14 plus 9 is 23. That's your 8th term. And 23 plus 14 is 37. That's your 9th term. And that's your answer. Next, 45,000 plus 129,000 equals what in scientific notation? Alright, so let's first add these two numbers. So 45,000 plus 129,000 is 174,000. Alright, from here we can convert it into scientific notation. I actually have a full video on this, which will be pinned in the pinned card at the top. Now let's continue with this problem. So 174,000. How do we convert this into scientific notation? Well, scientific notation is a form of writing a number where it's represented as a number between 1 and 10. So let's say A. So whatever number that we're writing in the scientific notation is between 1 and 10, and it is multiplied times a power of 10, so 10 power n. So usually it's something like x.xx times 10 to the power of n. Now what we fill in the x.xx and the n is up to the what number it is. So that's how we figure it out. So we have the number 174,000. So we just want it to be that there's only one digit before the decimal. So 1. However, how do we know what's right here in the n's place? Well, we count how much times you have to go back. So we go back once, twice, thrice, 4 times, 5 times. So our n becomes a 5, and we get 10 power 5. Now, what is it multiplied by? Well, we can see there's a 1.74 here. So that's all we have to write. 1.74 times 10 power 5, and that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, please make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.